Hi, welcome back to the Shiko Math Practice Lab, Learning Through Practicing. And we are in the unit of exponential growth and decay. This is our practice set number 3. And in this practice set, we're going to take a look at some very interesting problem about using the exponential growth and the decay formula. So we're going to take a look at Newton's cooling problems here and how to solve this kind of the problem. Okay, so that's our video number 3. Here is Newton's cooling formula and how do we do it. Okay, so let's take a look here. All right, so the okay, before, okay, we can do it here. Okay, so let's say a roast turkey is taken from an oven when its temperature has reached 185 Fahrenheit and is placed on a table in a room where the temperature is 75 Fahrenheit. If the temperature of the turkey is 150 after half an hour, what is the temperature going to be after the 45 minutes? And then the second question asks us is when the turkey will have a cool to the 105 here. So before we even do this type of the problems here, let me write down the Newton's cooling formula. Okay. So Newton's cooling formula is dT dt. See here, there's the uppercase T, we call this a temperature, and the lowercase t is the time. So this is the rate of the temperature change over the times, right? So the Newton's cooling formula is telling us this will be equal to the K, and then this is the T minus TS here. Okay, so what is your TS here? So the TS, this is what we call this the surrounding temperature or the room temperatures here. So like for this province here, it says the room temperature here is 75 Fahrenheit here, right? So really, so for this problem here, we can write this is the K and the T minus 75 here, right? Okay, so now in here, you know, if you take a look, if you let the T equal to T minus 75, if you say, hey, I will let this one equal to what? Equal to Y here, right? So then the dt dt, so you can say change it to the dy dt. This will be equal to what? It's K what? Ky is here. Then you say, oh my gosh, this is what when we first introduce, you know, the exponential growth and the decay, this is the formula we started derived from. From here, we say what? We derived this one, we say the yt is equal to the y0 ekts, right? We have to use this for all this formula here. Okay, so now after we say here, so we say, okay, so part A says if the temperature of the turkey is 150 after a half hours here. Okay, so now let's start to put back to this formula. So the Y0 is my initial temperatures here, right? So when the turkey was out of the oven, it's 105, right? So that's the temperature. So remember the Y is equal to T minus 75. So this is 185 minus 75. So this is my Y0s, right? So what is this one's here? This is 110 here. Okay, and then I can apply to this formula now and say the YT will be equal to the 110 EKT here, correct? Okay, so now let's say after a half hour, it dropped to the 150 degrees. That means the temperature dropped to 150 degrees. But then what is the Y going to drop to? Y going to what? Y value going to be what is 150 minus 75, right? Because we said we defined the Y as a temperature minus 75. So in here, they drop to 150. So the Y is 75. So now I can try to solve for what? My case, right? So it's 75 is equal to 1110 E the K. And what is my T here? T is 30 minutes here. So I can put it in here. Now I can solve it. So I will say E the K times 30 is equal to the 75 over 1110. And then you can solve the K. You take the natural log of both sides. So you can solve the case here. Let's try to, okay, maybe. Okay, so let's do this way. Let's don't skip any step here. Okay, so now we can take a natural log of both sides. So this is 30K is equal to the natural log of 75,110. Okay, now you divide it by 30 both sides. So I get the K is equal to natural log 75 over 110 over what? Over 30 here, right? So now I can plug back to my formula. So I will say YT is equal to what? YT is equal to 110 E2, right? So what is the case here? So K is 30. This is a natural log of 75, 110, correct? And times T here. Okay, so now the first question is what is the temperature after 45 minutes here, right? So what is the temperature for the 45 minutes? So you will say the Y, the 45 here will just be 1110 E, and this is the 30 natural log 75, 110 times 45 here. Okay. Okay, so you put it into the calculator and you can get this is 62, right? So don't forget this is Y values, right? So the real time, so the real temperature is T minus these T's, right? So I know T minus 75 is equal to 62. So T at the 45 minutes will be what? Will be the 62 plus 75. It will be 137. Okay. So at 137, right? So this is the temperature at the 45 minutes, right? So be careful here, right? Because Y is T minus 75 here. Okay, so now let's do the same way. Let's say, when will the turkey have to cool to the 105 degrees here, right? So 105 degrees here, right? So now, what is my Y here? So your temperature is 100 and what? Is 105. So now in here, so what is my YT? So what is my Y values here? So I know the T minus 75 is equal to what? Is equal to Y, right? So it will be 105 minus 75, so it's equal to what? Equal to 30. And then this is my Y values here. Okay, so be very careful, right? So now the Y is equal to 30. Then you can plug it into your formulas here. So this is 30 is equal to 110 E. And so this will be T times 1 over 30 and the natural log 75 over 110, right? Okay, so now you divide by 1110 and both sides here. So you will get 3 over 11 is equal to e to the t and 1/3 t natural log 75 110. Then you natural log both sides. So this is a natural log 311 equal to the t times 130. Then this is a natural log 75 110. Then you put the now you put it into the calculator and it will give you a t approximately to what? So the t will be approximately to the 102 minutes here. Okay. All right, so it's pretty cool, right? So the things we need to remember is here, right? This is Newton's cool formula here, cooling formula, and be careful that the only difference is here. This is in minus the surrounding temperatures here. So you need to let the T minus 75 is equal to the Y's here. Okay, let's take a look at another fun problems here. So it's for the murder investigations here. So we know the temperature of the dead body like was 32.5 degrees C when the the police arrive at 1:30 p.m. It's 32.5 degrees. Then after 1 hour, they measured again, it's 30.3. So we know the normal body temperature is about 37 degrees C here. Then and the temperature of the surrounding the room is 20 degrees here. Okay, so we want to see when the murder was, was taking place here. Okay, so now let's take a look what is here, right? Okay, so let's say that here we say the T to the time. So this is the temperature of your bodies, right? Okay. Okay, so this is the temperature of your dead body. Okay, so let's say the T0, right? So this is the first when the police arrive, they find it. So T0 is what? Is 32.5. And the T1, that means after 1 hour, temperature dropped to the 30.3. And what is my surrounding? My room temperature, TS, is what? Is 20 here. Okay, so now let's write the Newton's cooling formula again. Is dT dt, right? So this is a kT minus T surrounding. The surrounding we know is 20 degrees here. So this is T minus 20. Okay, so now we can do the same thing. We can say, hey, this is Y, right? So Y is equal to T minus 20 here. All right, now because this is Y, so this for here, this will become dy dt, see here. So it will become our, the exponential growth formula. So for here, this one, you can translate that to Y0. Y is equal to whatever the temperature minus 20. So what is Y0 here? Is 12.5. Then you can translate this one to Y1. So Y1 is minus 20 also. So what is this one? Is a 10 point what? It's a 10.3 here. Now we can figure that out. We can find the rate, right? Okay, so now we have this formula. We said YT is equal to the Y0 EKT. Okay, so we say after 1 hour, right? So this is 10.3. So after 1 hour, so that means 10.3 is equal to 12.5 is the initial E, the K. What is my T? T is 1 hour. So I can get the EK is equal to 10.3. This is 12.5. So what is my K here? My K is a natural log 10.3, 12.5. Okay, so now we have here, so Okay, so now I can find, okay, so now in here, my formulas here will be YT is equal to 12.5, and the K is natural log 10.3, 12.5 times T here. Okay, and then now for the normal temperature is 37, right? So we want to see how long the take it for the 37 to drop, right? Okay, so the 37, so now this is my temperature 37. So what is the Y values here? Will be 37 minus what? Minus 20 is 17 minutes here. Okay, so now you plug into this formula, so you will say here, okay, so this is 17 is equal to 12.5 E, the natural log 10.3, 12.5, the T. Okay, so now you can solve it. This is 12.5 and this is E. I can put this is 10.3, 12.5. I can move the T to the up here. Then natural log and the T cancel. So this will be 12.5, 10.3, 12.5 T. And we did this many, many times, right? So what you need to do, you take the natural log both sides. And so this will be, if you take the natural log both sides, and then you will have this is the natural log 12.5, and then plus the T, this is the natural log what 10.3 and 12.5, right? Then you'll be able to solve the T's here. So after you plug into the formula, then you find that the T is approximately equal to 1.59 hours. Then if you transfer the hours to minutes, you say it's about 95 minutes. Okay, that means you start with the normal temperature, body temperature 37, right? So you take about 17 minutes. No, you take about 95 minutes, right, to drop to the 32.5 here. Okay, so that's why we say it's about the 95 minutes. So that means it takes when they discovered it is 1:30, right? So we say it's 95 minutes before 1:30 p.m., right? Okay, so before the 1:30 p.m. here, so if you transfer that, so it's about when? So the murder probably happened at 11:55 a.m. here. Okay, so that is how do we do it? You see that? Okay, so that's why you start with, right, then you start like the 37, then you continue gradually drop to the 32.5 when they first discovered that. Okay, that's how much you decayed. All right, so that's it, and that's is the okay, so that is what we talk about this Newton's cooling formula, and how do we apply the exponential decay and the growth about it. Okay, it's nice to talk to you, and I guess we'll talk to you on our last topic is more to the business. So we talk about the interest, how to calculate the interest here. Okay, bye.